Hi, my name is Ellery Lennon. I'm a PhD candidate at the University of Miami, and thanks so much for coming to check out my research on nearshore fish assemblages near intact and altered mangrove shorelines in southern Biscayne Bay. Biscayne Bay is a highly altered watershed in South Florida, but the southern portion of the bay is the least developed and is dominated by mangroves. Mangroves provide fish with important habitat and serve as reproductive grounds, nursery habitat, foraging grounds, shelter, and refuge from predators. Biodiversity can indicate higher ecosystem functioning, and on their own, fish are an ecologically important taxa and fulfill many ecosystem services. However, the mangroves here do contain several canals, which alters these nearshore systems. I am using a large data set to attempt to define and characterize fish assemblages across southern Biscayne Bay. A fish assemblage is a group of species that interact and occur together and can be characteristic of similar sites. I retrieved this large set of pre-collected data online through iBeam, which conducts fish survey transects twice a year at several sites in southern Biscayne Bay. A single transect is just a snapshot of the fish community, so I combined transects from the last 5 years at each site to produce samples for these 12 different sites. 6 sites are near intact mangrove areas, while the other 6 are adjacent to mangroves that have been altered by canals. I then grouped these 12 sites into clusters and characterized each cluster based on species composition. The 12 sites formed 3 statistically different clusters. However, one cluster, cluster 3, contained 9 of the 12 sites, and these sites had a wide range of diversity values and were found across a wide geographic range. So I took a closer look at those 9 sites and found that they can be further split into 3 more subclusters. You can see that clusters 1 and 2 are characterized by a lot of different species, while cluster 3 is distinguished from cluster 1 and 2 only by 2 species of killifish. When I looked at the 3 subclusters, 3A and 3B had several distinguishing species, while cluster 3C was only distinguished from 3A and 3B by the sergeant major damselfish. The NMDS plots showed the spread of the sites, and you can see that they're clearly separated into their clusters. These clusters are correlated with salinity and depth, but temperature, dissolved oxygen, visibility, latitude, and shoreline type were not significant. You can also see on the NMDS plot on the right what fish species are responsible for the separation of these clusters. And while killifish are more abundant in cluster 3, all these other species are more abundant in clusters 1 and especially cluster 2. This shows us that fish are forming statistically distinct assemblages in southern Biscayne Bay. These assemblages are responding to salinity and depth, which shows that local water quality should be considered when restoring shorelines. Fish assemblages do not appear to be responding to shoreline alterations, but this is probably just because these alterations aren't severe enough, as these canals are still surrounded by mangroves. This has positive restoration implications because it shows that some level of alteration doesn't significantly affect the fish in the surrounding mangroves. Clusters 1 and 2 are more diverse, which indicates that they contain high ecologically functioning sites compared to the sites in cluster 3. It's really important to utilize these large data sets, particularly for ecological forecasting. My next steps are to follow up on the NMDS plot and explore what environmental factors are driving these differences in fish assemblages. So with that, I'd like to thank you once again for listening, and please reach out if you have any questions or comments.